Okay, in section 7.2, the one thing that I'm going to talk about is now that we've got this metric system thing going, it turns out that there's two ways that we can talk about volume in the metric system. So we're going to talk about the relationship We're going to talk about the relationship between volume measurements in the metric system. Before I tell you what the two ways to do volume are, what we're going to do is we are going to calculate a volume at this point in your math lives, because we haven't talked about finding volumes of things. That's going to come in the next unit after this next test. We're going to talk about finding volumes of things. But at this point, the only thing I expect you to be able to calculate the volume of is the volume of a box. So if you don't know how to calculate the volume of a box, then you're just about to be shown how to calculate the volume of a box. So a box, okay, I'm going to remember my middle school perspective here. That's not too bad for me. There's my box. Okay, so this is a box. Box has 3 dimensions. It's a 3-dimensional figure. Okay, so the way that we find the volume, meaning how much space does this box take up? Okay, the way we find the volume of it, does anyone remember? Let me ask you, does anyone remember how to find the volume of a box? Boom, yes. The volume of a box is the length times the width times the height. So labeling my box, it doesn't really matter. It's kind of arbitrary, but I'm going to call the length this one going backwards. I'm going to call the width the front here, and then the height is how tall is the box. The length times the width times the height. That's how you find the volume of the box. So for instance, let's do an example just to make sure we are getting more familiar with this. Let's find the volume of, we're going to find the volume of this box right here if I tell you the following dimensions. Let's say that the bottom of the box, let's say that, I'm going to keep the numbers just nice and relaxing. Let's say the bottom of the box is 10 millimeters. Let's say the length of the box is 20 millimeters. And then let's say the height of the box is 15 millimeters. All my units are the same. Okay, I'm not there. There's going to be no tricks or gimmicks as far as that as right now, just because we are just getting to know this. So then I say, okay, what's the volume of this box? So the volume is equal to the length times the width times the height. So I'm just going to take these 3 dimensions. I'm going to multiply them by each other. So I'm going to have the 20 millimeters, and then I'm going to multiply by the width, which I told you is 10 millimeters. And then the height, which is 15 millimeters. So what we're doing, I'm going to try to press into the point of what I'm trying to drive at this section. We've defined this box in terms of linear measurements, right? These millimeters. And now we're going to calculate the volume of the box, and that volume is going to be in terms of these measurements. But we also have another way to denote volume, which is liters in the metric system. So what we're going to do here in a moment, once we multiply this together, is I want to know what's the relationship between the liters, okay, or the different increments of the liters, and when I calculate the volume like this using my linear measures. So the number part of this, 20 times 10, that's 200. 200 times 15. Anybody know what 200 times 15 is? You got 3,000? I'm going to go with that. That's fine. You sound pretty confident. I love it. Now here's the thing. It's 3,000 watts. Not just millimeters. Yes, I've got it in 3 dimensions, right? So when I multiply something 3 times, it's millimeters times millimeters times millimeters. What that is millimeters cubed, cubic millimeters. So you can either write millimeters cubed, or you can write, I don't really care, cubic millimeters. That's fine too. So that becomes the other way to measure volume in the metric system. So the question that I want to answer is, what is the relationship between liters and cubic, let's just say, I'm just going to use cubic meters just because I'm picking a unit. What's the relationship between liters and a cubic unit? So which is a good question. And it's actually a fairly simple relationship. And then I just got a few problems for us to do to kind of solidify that relationship in our brain. So here's the relationship between various types of meters and various types of liters. So for instance, if you have 1 centimeter cubed, so my meter stick is right here, a centimeter is from here to here, just between my fingers, very small. So a cubic centimeter is going to look like just a tiny little box, like this is probably even too big for the centimeter cube. It's going to be very small little thing. So that's my cubic centimeter. I want to know, what is that equivalent to? 1 cubic centimeter is equal to 1 milliliter. Now the nice thing is it's just a 1-to-1 relationship. It's just changing the units. So that's nice and convenient. That 1 cubic centimeter is equal to 1 milliliter. If you're trying to think about how much a milliliter is, that's a little bit harder to determine, but a can of Coke, okay, if you drank a can of Coke or Pepsi or whatever your favorite flavor is this morning, that is about 350 milliliters, I think. So the 12-ounce can is about 350 milliliters. So it gives you an idea of how small a milliliter actually is. We could also say that 1 decimeter cubed, okay, so a decimeter is a tenth. That's what the prefix deci means. So on my meter stick, a tenth is again between my two hands. So if I make a box of that dimension, length, width, and height, all of that, if I have a box that's going to be about this big, maybe like a Christmas ornament, if you do that sort of thing, like that sort of size, that is going to be equal to, I believe it's 1 liter. So again, the nice convenient thing for us is it's a 1-to-1 relationship. There's no multiplying or dividing involved. It's just a conversion of the units. And then the last one is if you have 1 meter cubed. So if I have a box that stands this tall right here, and then is going to be this wide, and then it's going to be this deep, so about the size of your desk that you're sitting at, if we boxed it in, that is going to be equal to 1 kiloliter or 1,000 liters. Okay, so again, a 1-to-1 relationship. So again, I try to minimize the amount of trivia that you have to remember. I know you probably don't believe me at this point. You need to know the metric prefixes, and then you do need to remember this. These 1-to-1 relationships. When we get to the next section, I will tell you what you don't have to remember. Okay, so that's not, you don't have to memorize everything. So here's the typical problem that I'm going to ask you to do. I got one of these on the test, and I'm going to do one. I'm going to have you do 2, and then we'll be good to go. So here's what we've got. Let's say this. That's not the problem that I wanted to do. Okay, here's the problem I want to do. So here's what I want to do. I'm going to draw a box, and here the first question is, what is the volume of the box? And we've already talked about that. You can do that. And then I'm going to leave those conversions. I want to know how many liters does the box hold? Okay, we're going to answer these two questions in succession. And so here goes. I'm going to draw the box. These are the dimensions. Okay, so again, here's my incredible artistic talents on display. So the box looks like this, and so the bottom is 12 centimeters, the depth is 20 centimeters, and the height is 15 centimeters. So first thing, if you would do this for me, find the volume of that box, and then you can stop. You can keep going if you want to, but then you can stop. We'll talk about that together. Want to make sure we all have the same thing before we move on. All right, so the volume of the box. This is what we did an example of earlier, just because that's what I expect you to have as prior knowledge. The volume of the box is the length times the width times the height. Doesn't matter what order you do these. So it's 12 centimeters times 20 centimeters times 15 centimeters. And when you go through with your calculator, or if you did it out longhand, when you multiply 12 times 20 times 15, what do we get? 3,600, did I hear you guys right? All right, and then what's the units on that? Centimeters cubed, but yeah, it's cubic. So I asked you to convert this to liters, but before we can convert this to liters, we need to convert centimeters cubed into its appropriate pair. So what I would like you to do is, using this chart, okay, I'm going to give you like a minute to stare at the chart. We've got 3,600 centimeters cubed. That means that this box holds what? Okay, so look at the chart. Hopefully nice and it's straightforward in your face. And if you don't know what to do with the chart, that's okay. We'll see it in just a minute. Okay, so according to the chart, a centimeter cubed is equal to what? Okay, right here, a centimeter cubed, 1 centimeter cubed is equal to 1 milliliter. So this just becomes a label change. So instead of 3,600 centimeter cubes, I have 3,600 milliliters, right? It's a 1-to-1 correspondence. Now we can answer the last question. The last question said, I don't care how many milliliters, I want to know how many liters does this hold. So look back in your notes at the prefixes. The last thing is, now you're going to convert the 3,600 milliliters into liters, okay, by doing your hops, left or right or up or down, or whichever way you're going to take it. Okay, so when you looked at your prefixes to get from milli to liters, which is what the question was, how many hops and which direction do I take the decimal? 3 hops to the left, yes, because milli was at this end, the base, liters was right here, and so we moved 3, so 1, 2, 3. So that means that this box holds 3.6 liters of whatever liquid we are pouring into it. So this gives us an indication of the relationship between cubic units and the base unit of metric system, which is liters. So here's one more problem just like that so that you get to work through the whole thing. Again, the first question is what's the volume of the box? The second question, notice I've changed the units. I want to know how many kiloliters does this box hold? And here are the dimensions of the box. Front is 8 decimeters. The length is 12 decimeters. And then the height of this is 5 decimeters. And so I want to know how many kiloliters does this hold? All right, I'm going to get started on the problem. Keep working if you're not done. Check your work with my work. If you got any questions, be sure to ask it because this is going to represent the end of this section. And then I'm going to introduce the next section. The next section has just got one thing to introduce, but I want to do a bunch of practice. So we'll finish the day practicing and then we'll start up next week practicing from 7.4. Just because it's, again, it's probably one of the most important things that we will do for a lot of you in this class. Okay, so the volume of this box is 8 decimeters by 12 decimeters and times 5 decimeters. And then 5 times 8 is 40 times 12. Is that 480? All right. 480 decimeters cubed or cubic decimeters if you wrote that out. So far, we so good. We all right. Finding the volume of a box. Okay, I do assume that you can find the volume of a box. It's just length times width times height. This problem here, just like you're gonna, there's gonna be no tricks or gimmicks on the test. Don't worry. All right, so now we're gonna use our chart. We're gonna take this cubic measure. We're gonna bring it into the world of liters somewhere. So this chart tells me that 480 decimeters cubed is gonna be equal to what? Liters. Yes. It's going to be equal to 480 liters just by this middle row right here. Each decimeter cubed is going to be equal to a liter. It's a 1-to-1 relationship. So it just means you change the units. And then I didn't ask for liters, I asked for kiloliters. Okay, so I think if you turned back in your notes to your prefixes, how many hops and in what direction do we go to get from liters to kiloliters? 3 to the left. Yes, thank you very much. So 1, 2, 3. So this is 0.48. I'm going to leave the end of 0 off. If you put it on there, it's fine. It doesn't matter either way, and then that's kiloliters. Perfect. Yes. Can you write this? Yes, I fully encourage when you're taking a test and you have several things to remember, and I know there's a tenuous balance in our brain, I would do a brain dump. I would get a blank piece of paper when the test starts. I've got plenty here, and just do a brain dump of anything that you need to remember, like your prefixes and this. And then on this test, as far as stuff you have to memorize, that there might be another thing or two in the last section I don't remember, but it's not, I try to keep it to a minimum. But yeah, definitely do that. Don't come in with it. You can't bring a formula sheet in, but as soon as I give out the test, you can, wherever, write it down. Yeah, that's a great test strategy right there.